Welcome back to the CCNA video series. In this video, we are going to be having a look at this LLDP protocol. So the objectives for this video will be to understand what LLDP is, why we would use LLDP, and how to configure LLDP. So to begin with, what is LLDP? So LLDP stands for the Link Layer Discovery Protocol. And so this is another layer 2 protocol which resides at the data link layer, and it's very similar to CDP. So it allows a device to share information about itself to other devices, essentially saying, hey neighbors, this is information about myself. Those devices will then store that information in some sort of neighbor table. However, what makes it different to CDP is that LLDP, it is vendor neutral. Vendor neutral. That means that we can run LLDP on a HP switch, run it on a Juniper switch, run it on a Cisco switch, and those devices can use LLDP to actually send information about each other. So it's good for a vendor neutral environment where we have some Cisco, some Juniper, some HP devices, allows them to all share information about themselves, and then allows us to build this network topology diagram. So, like I said before, it allows a device to share information about itself with all neighboring devices by sending, like CDP, LLDP advertisement messages. And so this information that it shares about itself, each piece of information is an attribute about a device. And these are known as TLVs, so type, length, and value descriptions. And like CDP, LLDP will use a multicast MAC address to send these LLDP advertisement messages. The multicast MAC address is 0180C20000E. So if an interface has LLDP enabled, it will listen on that MAC address for any LLDP advertisements. So it's going to hold out its ear to the wire as soon as it receives a frame, and that frame has that destination multicast MAC address. It's going to process that frame. And so, like I said before, like with CDP, the reason why LLDP is a layer 2 protocol is because we only need to encapsulate that data within an Ethernet header and trailer, or within layer 2 information to actually move it from point A to point B. And like with CDP, once a neighboring device receives a LLDP advertiser message, it will not forward that message on to neighboring devices. So that message stays on the same link, on the same network segment. Essentially, if I receive an LLDP advertiser message from my neighbor, I'm not going to forward that onto my neighbors, okay? Instead, I will send my neighbors a LLDP advertiser message about myself. So like I said before, it's used for a vendor neutral environment. In this case, it will allow the Cisco device to tell the HP device, the Juniper router, the Juniper switch information about itself. It's literally as simple as that. And like I said before, this is good if we come into an environment where the network designer hasn't designed a network topology diagram. This will allow us to go into every device and essentially map out a network topology diagram by going into every device and seeing what that device plugs into. And so some of the information included in the LLDP packet, like with CDP, is going to be iOS version, host name, IP address information, native VLAN information, all that sort of good stuff. And also type of device, whether it's a router, a switch, a wireless LAN controller, a AP, all that sort of good stuff. So, unlike with CDP, on Cisco devices, LLDP is not enabled by default. And also, I would like to know that on Cisco switches, LLDP could only be run on Cisco devices running iOS version 15 and later. Okay, so the previous iOS versions, as far as I know, do not support LLDP. LLDP, once it's enabled, advertiser messages are sent every 30 seconds. So that is slightly different to the way that CDP works. So obviously CDP, those advertisement messages will be sent every 60 seconds. With LLDP, those advertisement messages will be sent every 30 seconds, which means that we have a hold timer of 120 seconds. So that means that if I don't receive a LLDP advertiser message from my neighbor within the hold timer, I will remove that neighbor's entry from my neighbor table. And so one of the good things about LLDP and why some people use it over CDP is LLDP. It gives us more granular control on what kind of information we can send to our neighboring devices. So essentially we can control which attributes are enabled, which attributes are disabled, which gives us more control over, I can send this information and only that information. So we can actually have control over what information we are going to send to our device about ourselves, to our neighboring device about ourselves. Now, LLDP supports a optional extension called LLDP MED. And now I know what you're thinking, what does LLDP MED stand for? So LLDP MED stands for LLDP for Media Endpoint Devices. So LLDP MED, that was designed and it was created specifically for voice over IP applications. Essentially, it allows your network connectivity devices, so your switch, or as Juniper's documentation, they talk about how to enable LLDP MED for your access point and your wireless LAN controller. But essentially, it allows your network connectivity devices, the network devices which provide a connection to your endpoints into the network. It allows those devices to essentially communicate voice over IP requirements, voice over IP settings. They were designed specifically for those devices. So it works with devices like IP phones, obviously. It works with devices such as soft phones, all those sort of devices. So it essentially allows us to communicate information to that device and allows us to tell that device its voice over IP settings or requirements so that we can have a better quality voice call. And so the way that it works is that your network connectivity devices, like your switch, so as an example, let's take your switch. Imagine that your switch is plugged into an IP phone. Your switch will send LLDP packets to the IP phone until it receives a LLDP MED packet from the IP phone. As soon as it receives that MED packet, the LLDP MED packet with the MED extension on it, it will start sending LLDP MED packets to the IP phone as well. And so, for example, we can use LLDP MED to notify an IP phone about the voice VLAN it should use. That way, we can put the IP phone into a separate VLAN, allowing us to have more granular control and also allowing us to apply quality of service to incoming packets from the IP phone. And so this TLV would be known as the network policy TLV. Okay, and so this kind of example demonstrates what kind of devices we can use with LLDP MED. So essentially, we have a switch here, a wireless AP here, and a wireless LAN controller. So essentially any device which provides you with connectivity into the network is going to be a device which supports LLDP MED. So not your router. Devices like a switch, as noted in Cisco's documentation, or if you read Juniper's documentation, they'll also talk about how to enable LLDP for the access point and for the wireless LAN controller. So the way it works, I'm going to be sending LLDP messages like normal. As soon as I receive a message from the IP phone or from any device which is using voice over IP, as soon as I receive a LLDP packet with the MED extension enabled, I'm going to start sending and receiving LLDP MED packets as well. So now let's talk about some of the optional or the additional LLDP MED TLV attributes. So the MED extension allows us to communicate certain or essentially more information to the IP phone or to the device which is running a voice over IP application. There's also the capability TLV that allows an endpoint device can advertise its capabilities and what capabilities it has enabled to the switch or to the AP or to the wireless LAN controller. The network policy TLV, this is very useful. So it allows an endpoint and also your switch, your AP, your wireless LAN controller or your network connectivity device. It allows them to advertise layer 2 and layer 3 attributes for that specific application on that specific switch port. So we can say to the IP phone, you can use this VLAN, or we want you to use this quality of service settings, etc. All that sort of information. The power management TLV. This allows for power management, hence the name. So for example, we can allow your IP phone and your switch to convey information such as how the device is being powered, whether it's voice over IP, whether it's being powered by a separate power supply. We can also allow the IP phone to say, if I'm going to use power over Ethernet, this is the power that I need and this is the power priority, all that sort of information, etc. We have the inventory TLV, which is part of the MED extension. This allows an endpoint to send detailed information about itself to the switch, such as as example, let's say it's an IP phone, the firmware version, serial number, manufacturer, all the sort of good stuff. Location TLV, and this provides the location information between the switch and the endpoint device. As example, this information could be the postal address, maybe where the device is located, or it could be the location of a caller. So if a caller is actually making a call, it can tell us that sort of information. And so by default, when we enable the LLDP MED extension, only the network policy and power management TLVs are enabled for LLDP MED. All the other TLVs have to be enabled manually. So takeaway from this, LLDP MED is used between a switch and an IP phone, or a switch and any device which supports voice over IP application. It just allows us to convey the voice over IP information. So it allows LLDP to convey information such as, let's say, your voice VLAN, let's say power over Ethernet requirements, all that sort of good stuff. So this shows a Wireshark capture from an LLDP packet. As you can see, it's only encapsulated within an Ethernet header and trailer, so layer 2 information, hence the reason why it's a layer 2 protocol, because it only needs layer 2 information to actually send that data. As we can see the MAC address of the device which sent this packet, etc., which is listed here. We can see the port type, time to live, port description. We can see the system name indicates this is a HP Procov switch. System descriptions, and this shows us, let's say, the revision number, all this sort of good information, capabilities, management address, and as you can see here, now we have the LLDP MED information, like network policy, location identifier. Shows here the endpoint powered via MDI, telecommunications, so power type, power priority, etc. All that sort of good stuff. Now, to actually configure LLDP, we can use the command. First, we have to enable LLDP on the Cisco device with the command LLDP run. And then the difference between CDP and LLDP when it comes to interface configuration is that with CDP, when we enable CDP on the interface, we enable or disable it for the whole interface. With LLDP, we can have more granular control. So we can say to an interface, okay, you can send CDP advertising messages, but you can't process or accept CDP advertising messages. So that allows us to essentially LLDP transmit, enable the sending of LLDP packets, LLDP receive, enable or disable the receiving of LLDP packets, all that sort of information. And also LLDP MED TLV select. Again, this allows us to define the media endpoint TLVs that we want to send in the LLDP packet. So now I'm going to pause the video. The next time you see me, I'll be at the command line of my Cisco switch. Welcome back, guys. So I'm now on the command line of my Cisco switch. If I do a show version command, okay, as you can see, I'm running version 15. So unfortunately, I've only got one device which is running iOS version 15, so only one device supports LLDP, but I can still show you some of the commands on the actual console line. Okay, so if I do show LLDP, as you can see, by default, LLDP is not enabled. So now we have to enable it. Go into global configuration mode, use the command LLDP, and it's going to be run. Okay, and as you can see, if I go here, LLDP TLV select, as you can see, I have more granular control. So I can choose whether I want to send this information, so system name, whether I want to include that information when I send the LLDP advertising message to my neighboring devices. So more granular control over CDP, which is one of the benefits. System name, I want to include that, as you can see, and then if I don't want to include that, I'll do no LLDP TLV select system name, and then that means that I will not include this attribute when I'm sending information about myself to my neighboring devices in those LLDP packets. LLDP, let's see, we can configure the reinitialization timer, we configure the hold timer, the timer which specifies the rate at which we send these packets, etc. All that sort of good stuff. So if I do timer, let's change it to 5 seconds. Sorry, 5. Bloody hell, 5. Can't type for some reason. LLDP hold time. Let's end that to 20 seconds or something. Exit from here. Show LLDP. Do again enter. As you can see, it's active. We can see advertisements are being sent every 5 seconds, and so by default, the reinitialization delay time is 2 seconds. The hold time is I've changed to 20 seconds. Okay. Show LLDP interface. Let's see this command. And as you can see, when we enable LLDP globally, by default, it's enabled on all interfaces. Okay. So let me change some of the settings. Here you go. Interface FA0/1 LLDP. As we can see, we can change the MED TLV select. Include all this information. Let's do network policy. Let's enable the inventory management. Let's enable power management, etc. All that sort of stuff. Location as well. LLDP. So let's do no LLDP transmit. Okay. This is, again, this gives it even more granular control, as well as defining what TLV values or what TLV attributes we can send globally. We can actually change the TLV attributes that we send out per interface. So I could say, this interface, I only want to include certain information about myself. This interface, I want to include other information about myself. So as you can see, such granular control over what information we can exchange, which is one of the reasons why you may use LLDP over CDP. So if I go interface FA0/2 and do no LLDP receive, if I go back over here and do a show LLDP interface command, as you can see, and as you can see now, it says, okay, I'm not going to transmit LLDP packets, but I will be happy to receive them. And over here, I'm going to transmit LLDP packets at this interface, but I'm not going to any LLDP packets I receive on this interface, I will not process them. So you can see such granular control. Very, very good. Show LLDP. As you can see, I can look at the traffic. In this case, this is how many LLDP frames I've sent out. Show LLDP. If I do neighbors, this will show us my neighbors. As you can see, I don't actually have any. Unfortunately, like I said before, I don't actually have another device running iOS version 15, so I can't show you like how I did with CDP. And so it lists the device ID, and again, if I wanted to view detailed information about all my neighbors, I can do a detail command. Okay, if I wanted to list detailed information about one neighbor, I'd use this show LLDP entry, and I would then specify the LLDP entry based on the device ID. So again, the commands are very similar to CDP. It's essentially the same as CDP in what it can do, but it gives us more granular control of what information we can send and receive to our neighboring devices. And so that's it, guys. So that's LLDP explained in its full. So that's a detailed explanation of why we use LLDP. Again, just to recap, same as CDP, but it's vendor neutral, so we can use with other devices which are non-Cisco. And it gives us, as you can see from the command line, gives us much more control over what information we can exchange, either on a global basis or on a per interface basis with the neighboring devices. Again, with all these examples, this is just to show you how to use the technology. I would highly encourage you to set up your own lab and practice these commands. Again, make sure that you have purchased an iOS version 15 enabled device. If you found this video useful, then please subscribe to my channel. If you found this video useful, then please share so that we can get high quality IT training to the masses free of charge. Thank you very much for watching.